So we're on lesson 5-3, and we're identifying and writing proportions. So I thought we'd take a look at some shapes. I wrote two shapes. I have a 10 by 5 rectangle and a 20 by 10 foot rectangle. We can think of them as little patios or something. And we want to see if they're proportionate. The two ratios, the relationship between their width and their length, are the same proportion or have the same relationship in terms of their width and their length. So this one is a length of 10, so it's a 10 by 5, and this is 20 by 10. The way the book recommends you determine if two ratios are proportion is to write them like fractions. Here we have a 10 to 5, and we already went over how to write ratios in three different ways, and this one is 20 by 10. And one procedure is to write them in their simplest forms, treating them like they were fractions, and we can simplify ratios just like fractions. So let's simplify this. Find the greatest common factor between 5 and 10. In this case, it's 5. We divide both the numerator and the denominator, or in this case, the length and the width by 5. And 5/5 is really 1. If I divide something by 1, I don't change its value. 10 divided by 5 is 2, and 5 divided by 5 is 1. So this rectangle has a 2 to 1 ratio. 2 to 1 ratio in terms of its length and width. So for every 2 feet long this rectangle is, it's 1 feet in width. Let's see if this one has the same proportion. So I can think of it like a fraction, do the same procedure as simplifying fractions. I have 20 to 10 ratio. Find the greatest common factor between 10 and 20. In this case, it's 10. And so divide both the numerator and the denominator, or the length and the width, by 10. 10/10 is really 1, so if I divide something by 1, I'm not really changing its value in terms of its ratio. And 20 divided by 10 is 2, and 10 divided by 10 is 1. So this also has a 2 to 1 ratio. So for every 2 feet long this is, it's 1 feet wide. Let's take a look at a couple more rectangles. Here we have a length of 8 by 12 and a length of 5 by 20. So let's do the same thing. I'm going to write an 8 by 12, and this one has 5 by 20. And I can simplify these. Greatest common factor between 8 and 12. Let's try 8. Well, 12 can't be divided by 8, so 4. 8 divided by 4 is 2. 3. So this has a 2 to 3 ratio. For every 2 feet long, it's 3 feet wide. So for 2 feet long, it's 3 feet wide. I just drew a proportional rectangle inside it. And let's try this one. So this has a 2 to 3 proportion. 2 to 3. And this one is 5 by 20. So 5 divided by, the greatest common factor is 5. 5 divided by 5. 20 divided by 5. We have a 1. 4. So for every 1 foot in length, it's 4 feet in width. So these two rectangles are not the same proportion, and we can tell, actually you can tell just by looking at it, this one is a lot wider and not as long. This one is a little longer and still pretty wide. A 2 to 3 ratio as opposed to a 1 to 4. So they're different sizes and different proportions, as well as these two are different sizes, but they have the same 2 to 1 proportion or ratio in terms of their length and width.